For the second video of 9.4, we're going to cover what appears to be a question very similar to question number 8 on your MyMathLab problems. Now, in these types of problems, what you're going to look at is a slightly different setup. In the previous problems, or the previous video, we talked about an equation that was A equals P times 1 plus R over N to the power of NT. That had the situation where we were putting money into an account and we were leaving it alone. This type of problem is slightly different. This problem says find the savings plan balance after 3 years with an APR of 9% and monthly payments of $300. Now that seems like it might be misleading in terms of a savings plan and us making payments. Don't think of it in terms of payments, think of it as in terms of deposits. So now what we're doing is we're no longer making a lump deposit of, in the previous video, like $30,000. We're going to make installments of $300 a month, which seems like it's more reasonable for some of us to be able to do. So this problem seems more likely for the real world to happen. It's very unlikely that you'll be able to put away $30,000 in one lump sum and just let it sit for 5 years. So let's see if we can do this problem. Now, the first thing we have to understand about this problem is that it requires a different formula. Now this formula we didn't build yet, and I'm not going to build it, but we're just going to go ahead and set it down. Now, the formula that you're going to see on MyMathLab looks something like this, where you're going to have the A, the amount that you're going to end up with, is the payment multiplied by this obnoxious looking fraction, which you'll notice this piece right here looks something very similar to something we've already seen. This piece right here to the power of NT. That is actually, if we recall it, the factor to the power of the number of times we were compounding it. This is all divided by APR divided by N. Okay, so very carefully, this is the formula we're working with. Now let me go ahead and rewrite some details so that's more clear about what we're really trying to do. First thing is, in the problem we were given is T equals 3 years. Second detail is that APR is 9%. And finally, the monthly payments, the PMTs, okay, those are $300. I'm no longer going to look at them as PMT. I'm going to look at those as a deposit, a DEP. Because again, it's more reasonable for us to look at a savings plan and talk about deposits than look at a savings plan and talk about payments. So, with all this being identified, we're going to go ahead and just plug in all the details. Now, there's one piece that's not clearly stated, and that's this N value. What is N going to be in this problem? Well, remember, N is the number of times we're compounding it. And since this is a savings plan and we're making monthly payments, I would have to argue that this is going to be N in terms of months. So what we're going to do here is we're going to change this formula. It is going to be A is equal to the deposit that we make multiplied by 1 plus APR divided by N to the power of NT minus, I'm sorry, there's supposed to be a 1 right here, okay, minus 1, that's all on top, divided by APR divided by N, that's all on bottom. So you have one giant thing up here, you have one giant thing down here, and it's all multiplied by that deposit. So if we plug in all these values very carefully and very succinctly, I'll plug in the 300 for the deposit, I'll have 1 plus my APR is 9%, but remember, anytime we're working with numerical values, you have to remove the unit of percentage and change it to a decimal value. So that means that we're going to have 1 plus my APR is 0.09 divided by the number of times we're compounding. And again, since we're making monthly payments, I'm making an assumption that this is a 12. This thing here is to the power of N, 12, T, 3 years. Again, the number of years is 3. That value there, minus 1, all divided by my APR, which is 0.09 again, divided by 12. So, this is the formula we are attempting to evaluate. When we do this, we'll have to do it in very, very careful steps. The 300 is not going to change as I go through any of these details. I'm going to do piece by piece. First thing I'm going to do is identify that this value right up here is 36. I'm going to make a note of that. That's my power. My power is 36, 12 times 3. I can do that one without an issue. My next detail that I'm going to try and evaluate is what is, in my calculator, 0.09 divided by 12. If I can do this correctly, that provides me with approximately 0.0075. Again, if you can see it on my calculator, that's great. If not, I'm going to write it down either way. So this is going to be 300 times. Well, if I take 1 and add 1 to that division value, I end up with a factor of 1.0075 to the power of 36 minus 1, all divided by, and what was the value that we had for 0.09 divided by 12? Well, we just did that, the 0.0075. So I'm going to divide it by that value. Notice we're not adding or subtracting anything to this bottom number based on the formula that we have up here. So after I've done that, I'm going to very carefully take this number, 1.0075 to the power of 36. I'm going to take 1.0075 to the power of 36. I'm going to go ahead and subtract 1 from that immediately. I'm going to go ahead and, with my calculator the way it's set up. Now, if you're not able to do this, if you do not have a scientific calculator, by all means, write down the values and every single decimal numerical value that you can fit on your paper from your calculator to make sure that you can retype it back in with as many decimal places as possible. Again, the reason for this is to avoid any rounding errors, because you're not supposed to round at each step. You're supposed to round at the end. Okay? So, now that I have this decimal value, I can divide it by 0.0075, which I'm going to do in my calculator again. I'm going to take that value, I'm going to divide it by 0.0075, and then finally I'm going to multiply it by 300. In doing so, I end up with a value, and I'm going to go ahead and move my paper here so I can see it. This value ends up being an amount of $12,345.81. Now again, clearly this value is a little bit off, but it seems like if we're making $300 deposits over the course of 3 years, every month, that amount of money multiplied by 3, multiplied by 12, again, n, the number of times it's deposited, we're going to end up with quite a large chunk of money, and then the interest is going to take care of the rest. Keep in mind that interest is an APR of 9%, which is not likely in a savings account. So that there is the second type of formula we're going to have to deal with when it comes to these problems. So very carefully make sure you follow the formula, make sure you identify n, my APR, the number of years, and the payment amount. And plug it all in and very carefully simplify step by step. That is all that there is to 9.4. Just very carefully follow the two different formulas.